Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 5.3, was looking at solving quadratics with complex numbers. So basically we're going to be solving quadratics just like we did in the previous sections, units 3 and 4, but in these cases we're going to be getting imaginary numbers, which we covered in the intro to unit 5. So we'll go ahead and get started. Here, the first few questions that it gives you in the assignment, if you're following along directly through the assignment, are pretty straightforward. It'll just be something like x squared equals negative 16. Technically, this is a quadratic equation that has a complex solution because it's going to end up with an imaginary number. Remember, complex numbers are made up of both real and imaginary parts. Sometimes we have both, but either or, that means it's a complex number. So let's look at this. Here I have x squared equals negative 16. Because I don't have a b term, I don't have just an x, I would just simply take the square root. So you get x equals plus or minus the square root of negative 16. Remember that when you have a negative square root, you can break it apart into its two parts. So here I would have plus or minus, and then it's square root of 16 times square root of negative 1. Square root of 16 is, of course, 4. And then by definition in 5.1, we said the square root of negative 1 is I. So your solution would be x equals plus or minus 4i. You can write it as a single answer like that with the plus or minus symbol, or if you want, you can write it out separately. X equals positive 4i, x equals negative 4i, but it's essentially the same idea. Okay. Let's look at another example. So let's do x squared plus 2x plus 10. So if I want to solve this, typically, if I have an equation symbol, if I have an equal sign, that means I'm wanting to solve something, but always read the directions carefully. So you can use typically other methods when we're solving, but if I'm looking at complex number solutions, that means that I want to use the quadratic formula. So remember, quadratic formula from previous sections is x equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So I'm going to plug in my a, b, and c values here. So I have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 10, and that's all over 2a. It's all over 2 times 1. If you need review, the 4.6 video is going to go over the quadratic formula. So if it's been a while since you've done this, I would recommend watching that first and getting those notes down, and then using this for 5.3. So we're going to follow order of operations. I have negative 2 plus or minus square root. 2 squared is going to give me 4. 4 times 1 times 10 is going to give me negative 40. And then over 2 times 1, which is, of course, 2. We'll continue to simplify. Inside the radical, I have negative 2 plus or minus square root. 4 minus 40 is negative 36, and that's all over 2. Then I'm going to evaluate the square root now. So if the square root of 36 is I, or if the square root of 36 is 6, then the square root of negative 36 is 6i. And we already have that plus or minus symbol written into the equation. So negative 2 plus or minus 6i, and that is over 2. Because these are both even, I'm going to divide the two parts separately by 2. So my final answer is going to be x equals negative 1 plus or minus 3i. So pretty straightforward. It's just like 4.6, but now that we're ending with a negative number in our discriminant, we're going to have both in a real and imaginary part, thus the complex numbers. Let's keep going here. Let's do another one, number 3. 4x squared, let's do minus 3x plus 15. So then I'm going to go in and plug in my numbers into the quadratic formula. So I have x equals negative b, being careful with the signs. So my b is a negative 3, so that's going to change to be a positive. Plus or minus the square root of b squared minus 4 times a times c, and that's all over 2a. Then we go through and simplify. The two negatives cancel out. So I have 3 plus or minus the square root. Negative 3 squared gives me 9 minus 4 times 4, that's 16. And then 16 times 15 is going to give me 240. All over 2 times 4. Subtract inside the parentheses set, so I have 3 plus or minus the square root of 9 minus 240, so negative 231, and that's all over 8. So from here, we do want to take the square root, but remember that if we can simplify the radical, we always have to, just like we did in 4.6. And sometimes just as coincidence, because we're pulling random values here for A, B, and C, sometimes you can't simplify the radical. So here, because negative 231 cannot be simplified, all I'm going to do is pull out that negative 1. So this is going to be 3 plus or minus the square root of 231i, and then all over 8. Depending on the instructions in the assignment, sometimes you can just leave it as is once it's been simplified. So this would be your final answer. Or if you want to separate your real and imaginary parts, you could do x equals 3 over 8 plus or minus, and then radical 231 over 8i. So that's it for this section. Same steps as 4.6, just know that you're going to end up with an imaginary number potentially. Eventually, you're going to be given just quadratic problems where you don't know if you're going to have a real solution, no solutions, or an imaginary solution. But we will cover this more in class. If you have questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon.